Good day, everybody. Welcome to the PEM and REM 2014 webinar series on asset management and reliability. My name is Lisa Naich. I'm the Associate Publisher of Plant Engineering and Maintenance and Resource Engineering and Maintenance, and today we're very excited to bring you Part 1, Risk in the Asset Management Context. Before we start, I'd like to take a moment to listen to some information supplied by our sponsors, Mobile Industrial Lubricants.
This webinar is sponsored by Mobile Industrial Lubricants. Civilization depends on manufactured goods, from food to transportation to building materials. To meet this demand, manufacturers rely heavily on machinery. High-performance lubricants and best-in-class lubrication practices are essential to ensure that machinery continues to operate reliably and at peak performance. Mobile Industrial Lubricants excels at both, developing and bringing you high-performance lubricants and supporting you in implementing sound lubrication practices to help extract peak performance from your machinery. Since 1914, we have closely collaborated with the world's leading equipment builders to understand equipment trends, as well as current and future lubricant requirements. We consult on lubrication system design and help troubleshoot field lubrication issues. The insights that mobile engineers obtain in working closely with equipment builders are factored into our lubricant formulations and programs. Our knowledgeable field engineering services team supports our customers to implement programs and practices that help enhance operations and streamline maintenance practices. More specifically, they strive to help customers enhance their competitiveness and meet their business goals by helping extend equipment life, reduce downtime, extend oil drain intervals, and minimize lubricant, energy, and equipment waste.
So right now, I'd like to introduce our speakers today. James Reyes-Picknell, co-founder of Conscious Asset Management and one of our regular contributors to PEM and REM magazines, author of Uptime, Strategies for Excellence in Maintenance Management. And today's webinar will be moderated by Rihanna Begg. Rihanna is the editor for PEM, Plant Engineering and Maintenance, and REM, Resource Engineering and Maintenance magazine. I'd like to do a few housekeeping details before we go forward. And first of all, anyone who's part of this presentation is registered. After the presentation is done, you can download it by visiting www.pem-mag.com/webinars. If we have any questions that you'd like to post, anyone logged in again can ask the speakers a question by entering it into the question and answer box and then click submit. We will get to as many as we possibly can, time permitting. Any technical problems, please send a question from the question window, or you can call toll-free numbers shown on the screen. And at the very end of the webinar, if you'll please take a moment to answer a very short survey and let us know your thoughts. I'd now like to pass the webinar over to Rihanna.
Thank you, Lisa. Good afternoon, everyone. Welcome to the 2014 PEM webinar series. Our theme, of course, is asset management and reliability, highlighting the practical implementation of maintenance solutions. In this three-part series, we have purposefully tied together solution-based presentations, and they will focus on key knowledge areas such as change management, integrated maintenance strategies, analytics, and of course, today's topic is risk. Excuse me, it is my pleasure to introduce James Reyes-Picknell, who is a longtime friend of PEM and REM of both brands. Excuse me. Jim is a columnist and a frequent contributor, and most of you will know him as the author of Uptime, Strategies for Excellence in Maintenance Management. His book is widely used and, of course, highly regarded by maintainers around the world. Jim has a 36-year background in maintenance, reliability, and physical asset management in a range of industries and locations around the world. Jim is a co-founder of Conscious Asset, that's his business. He's a registered professional engineer, a certified management consultant, and certified maintenance and reliability professional. Welcome, Jim. I think we should start today with first talking about a framework and a context of risk. I read recently a published global survey of more than 300 companies conducted by Forbes Insights. The survey said that 94% of these respondents, of the 300 companies, they say they aren't just increasing their focus on managing strategic risk, they are changing how they do it. Most often by incorporating strategic risk management into their business strategy and their planning processes. So why don't you start us off by telling us, what is risk, and then relate it to us in the physical asset management environment.
All right, well, thank you very much, Rihanna. Well, risk itself, in a purely grammatical sense, it's a noun, a situation involving exposure to some sort of danger. Um, Also, the possibility that something unpleasant could happen. Um, it's a person or thing likely to turn out well or badly. Uh, Risk can have several different meanings as a noun itself. It can be a threat. It can be a source of danger. Um, it's the possibility of harm occurring or damage, something you don't want to happen. And of course, in the business context, it's generally considered to be the possibility of a financial loss. Now, it's also a verb, and we don't really use it that much in this field, but as a verb. But it's to expose someone to danger or harm. You're exposing them to risk, but you're putting them at risk in doing that. And industry to industry, you'll find that there's also some variation in how the term is used. So it's not a consistent term, even though there is a standard, an international standard on risk management, which I think sums things up nicely, and I'll get to that a bit later. But the industries themselves have a variety of different uses of it. Now, and in the asset management world, you'll find that it's relatively new. The term in finance, food manufacturing or processing, the insurance industry, security trading rather, and in the workplace itself, you're going to find that there's different meanings, right? In the workplace, it's often about safety. In securities trading, it's about a financial risk. In insurance, you're insuring risk, essentially gambling against yourself. In the food industry, the risks are that you will injure or kill someone. Financial risks themselves are quite varied. You've got capital risk, country risk, default risk, delivery risk, economic risks, exchange rate, interest rate risks, liquidity risks, and on and on and on it goes. So the financial world has used this term quite extensively. Now, from an industrial perspective, we've got an international standard, ISO 31000, and the guide that goes with it. The standard itself was most recently modified and republished in 2009. The guide is from 2002. And it defines risk as the effect of uncertainty on objectives.
Okay, what does that mean?
Well, that could mean a couple of things, actually, in my view. One, very positive. There's a risk that things will turn out well for you. When you buy a lottery ticket, you're gambling that you're going to make money. When you buy an insurance policy, you're gambling that you won't lose money. So it can be positive and it can be negative. But in both cases, you've got a degree of uncertainty that you're dealing with because you don't know what the outcome will be. There is a probability associated with it. It might be high, it might be low. And that's really what risk is all about is what are your objectives, what are you trying to achieve, in other words, and what are the uncertainties that could impact that, and what's the effect of those.
So Jim, with this increased urgency, I want to say, with risk, I mean, if strategic risk has always been part of the business, why now in physical asset management are we seeing this upsurge? Why are we talking about this now?
This is going to sound kind of silly, but we're waking up to it finally in the physical asset management world. It's always been there. It hasn't always been paid attention to as well as it might have. The risk of failure of equipment has always been there, and we've always known it. Arguably, that has become more noticeable in recent years, partly because we design equipment differently. Back in the mid 20th century, before when some of our audience was born, I'm sure, I'm certain equipment was sold by the pound. It was built very robust, and some of that stuff that was built 50, 60 years ago is still in operation today, and is running just as well as it did the day it was first put into service. It was built big and beefy. Stuff like that just doesn't break. Today, we use very sophisticated engineering techniques to make maximum use of materials so that we minimize the use of the material itself and get the most strength out of it. So, aircraft couldn't fly if we built them big and beefy. For example, cars today, they're making them lighter. They're making them of composite materials, and the idea being to have strength without weight so that you have fuel efficiency and better economy. So the materials are being more highly stressed. So when they will fail a little bit more dramatically, simply because of the high levels of stress. The other thing that is, I think, driving it is the fact that we know about things going wrong, right? When the recent Malaysian Airlines flight went missing, we all knew about it probably before it even crashed, and we still don't know where it crashed. So the communications works incredibly quickly today, and you hear about disasters and events very, very fast. And in the world of engineering, arguably engineers, we're trying very hard not to kill people, of course, and injure them. But when it does happen, we tend to do it in big numbers. So, when a plane crashes, it doesn't happen often, but it usually knocks out a few hundred people at a time. When a bridge collapses, cars and trucks fall off, people drown, and so forth. It makes the headlines. And the world is becoming more and more aware of these things. The fact that news travels quickly, when something bad happens somewhere in the world, we all hear about it. So risk is just becoming an everyday topic. And when stuff goes wrong, it makes great news coverage. So, sad as it is, but we tend to like that kind of news. So in asset management, now it's not totally new, but it's relatively new. The first appearance of any kind of talk about managing risk really appeared in work done by Nolan and Heap back in the 1970s, when they studied the failures of aircraft, and they actually expressed their statistics in terms of crashes per million operating hours, which is a fairly significant thing when you think about it. How many crashes per million hours would you like to accept? It's kind of a scary concept. But
that just brings up the idea of how tolerant you are for risk.
It does.
I think we're going to go into talking about a little bit more about the concept of tolerance and people's tolerance to risk. I'd like to put up a poll as you talk about that.
Sure.
And so people can just vote on it. And the question is, what probability of being killed in a fire would you accept? Jim, talk to me a little bit about the idea of risk tolerance.
Well, we all have different levels of risk that we'll tolerate. Right? Like I run my own business, so I have a fairly high tolerance for business risk. People who are employees typically don't. Right? That's somebody else's worry, not theirs. They want the job security, for example. I view it very differently. Right? I say the best job security is a job you can't get fired from, and I can't fire myself. So to me, that's very secure. But it's a different perspective, and my perspective will be different from yours and that of many others. None of us want to see people killed, all right, or injured on the job, for example. But we do live with those risks, right? Even in an office environment, there's a probability that you could be, eaten up and spit out by a photocopier, I suppose. But there is actually a probability you could be killed in the working environment, even in an office. Industrial facilities have a higher probability that it could happen. When you're driving a car, you actually have a very high level of risk that you could be injured or killed in a car accident. On an airplane, it's actually a lower level of risk. And we tolerate those risks all the time. Now, if I look at this, what probability of being killed in a fire would you accept? And we use the word accept here very precisely. Obviously, people want it to be very, very low probability, right? In fact, if you had 0 up there, I would wager that most people would have picked that. If I asked you what you tolerated, you might get a different answer.
Okay.
Because accepting and tolerating are not the same, right? We don't accept death in the workplace, but we tolerate it. It happens,
Right.
and we live with it. Even if we don't like the idea of it, even if we find it unacceptable to have people injured and killed in the workplace, we still live with that risk that it will happen. So we are actually tolerating it. So there's a difference between what's acceptable and what's tolerable. In a fire situation, clearly we don't want that to happen, but we live with it. Your workplace is probably less prone to fire than your home is, and yet you'll feel safer at home because you have control over that environment, or you believe you do. The consequences are the same. Dead is dead, regardless of where it happens. But the exposure to that risk changes from environment to environment: car, airplane, home, work. And what we find as tolerable will probably vary from location to location. Right? If you have more control over something, you're prepared to tolerate a greater risk, even though the level of acceptability might still be zero, or 1 in 10 million, as we saw on the poll here.
So there's no such thing as zero tolerance.
There's really no such thing as zero probability of something going wrong.
Okay.
Okay. If you're in a workplace environment, for example, and many safety programs say, well, we want zero harm, zero injuries, zero fatalities, and so forth. It's a fantastic goal to have in mind. But if you've ever actually had an accident in the workplace, you're already above zero, and you can never go back down, right? You can't undo history. So now you could start counting today, but would you ever really achieve zero? And statistically, I highly doubt it. It's a noble target, no argument with that. It's certainly more acceptable to say that we tolerate zero, but in reality, you live with a risk. So your actual tolerance and what you find acceptable won't be the same. All right, and everybody's going to look at it differently. So there's a concept here that you're going to lose something of value, and there's a potential of doing that. It could be your life, it could be money, it could be production. You're interacting with uncertainty at all times, right? Even just sitting here listening to this webinar in your office or in your home, wherever you are, there are risks that you're exposed to of one sort or another. Heck, you're even exposed to risk from radiation from your cell phone. If your computer is on a Wi-Fi, there's some electronic radiation that's actually probably flowing right through your body right now. Is there a risk from that? Yes. Is it high? No. All right. Some risks can be quantified very well. Some are not so easy to quantify. All right. Levels of tolerance can be quantified quite often, and they're often quantified by looking at historical performance, risk performance. So the quantification can be a little bit inconsistent. People talk about, if we could flip to the next one there, yeah. The commonly accepted way of quantifying risk is to say the probability of an event multiplied by the cost or benefit, if you're looking at a positive type of risk. But does that really mean much to anybody? A probability has no dimension. It's like when you roll a dice, you have a 1 in 6 probability of getting any single digit that you could name, right? Sure. And that's the concept behind probability. What does that number mean to you, right? If you're, in a gambling casino and you roll a couple of dice and you roll a pair of sevens, there's some benefit you stand to gain, right? And there's also some money that you've paid and gambled that you could lose, all right? The probability of getting 2 sevens is actually 1 in 36, right? It's 1/6 times 1/6. And so the probability of winning is actually quite low. The probability of losing is 35/36, if you think about it, because there's only one pair of sevens, and there are 35 other combinations. So you're putting a small amount of money at risk in order to gain a larger amount of money, right? So there's a cost, and there's a benefit, and there's a probability associated with it. You could also look at the probability of a threat of some kind of quantifiable damage, right? Like risk doesn't necessarily have to be a dollar thing. It could be a certain amount of production loss. It could be the risk that somebody is injured, somebody is killed. It could be the risk that a large number of people are killed. It could be the probability of a plane crashing. You know, it doesn't have to be a dollar value. It could be anything. So quantifying it's not always going to be consistent, and it's not always going to be in the same units of measure every single
Right,
time.
so are you saying that every organization should be developing its own benchmark?
They should have their own risk management framework.
Hmm.
Not so much a benchmark, but within that framework, they probably will have a way of measuring it.
Hmm.
And it may be a mix of measures. All right, like I'm sure, for example, in the let's take the aircraft industry. You know, there's a probability of a plane crashing. Well, they're not really looking at the cost. I'm sure somebody's looking at the cost of it, but it's more of a flight safety thing and a very human thing that's at risk here, life, basically. But there's also risks associated with getting the meals to the airplane on time so that the customers are happy. And if you're not making the customers happy, they may not come back. So there's actually a financial risk related to customer service. So there's different risks in virtually every organization that you will quantify differently. Right? And in the heavy industries, oil, gas, pulp and paper, you know, the utilities, there's often a risk matrix that talks to impact on the business, which could be financial. It could also be a multiple scale. There's a financial scale, there's a safety scale, everything from, you know, a near miss up to fatalities or multiple fatalities, and there'll be probabilities associated with that. So the higher risk items are the things that have the higher probabilities and the higher consequences. Okay, so that's quantification typically. Let's look at risk management approaches a little bit. Now, risk management itself is actually a systematic approach to setting a course of action, which involves uncertainty, of course, how you're going to deal with it. But first of all, identifying what the risks are, assessing how severe is that, understanding the consequences of the events that are going to occur if that risk actually, or that event actually happens. What are you going to do to act on it? And how are you going to communicate this to the people that are involved, which could be, depending on the industry, a large number of people. The stakeholders in the industry could actually include neighbors outside a plant, right? You can imagine if you think back to the 1980s when the major cyanide gas release occurred in Bhopal, India. Right now, there probably wasn't an awful lot of public interaction with the plant. People just worked there and they lived outside the gates. You can bet to this day there's probably some pretty good public awareness programs going on there, simply because of what happened. And you do see that in the chemical industry and its marketing efforts, its public relations in the communities where plants tend to be sited. You'll see there's quite a bit of communication. At one time early in my career, I worked with a major chemical company here in Canada, and we actually had practice evacuation runs. Right, if something were to go wrong, there were evacuation routes in the community, and there was actually quite an orchestrated practice of evacuating part of the city. So there was a tremendous interaction with the local community in the event of something going dramatically wrong. And that was actually a risk management activity. If you think about it, it didn't necessarily address the probability of something happening, and it didn't necessarily eliminate the source of the danger, but it did deal with the consequences. Right? Get the people out of there so that nobody's hurt.
I would have thought this is more of a crisis management activity.
Well, crisis is what you have after the risk is realized. Risk management is actually about dealing with the crisis before it occurs. Now, one risk management strategy is to accept the risk. In other words, let the crisis happen. You typically would not do that unless the consequences are fairly minor. Okay, but in risk management, in fact, I'm going to get to this in a minute here. There are a number of different choices you can take, and crisis management is okay. What happens when things go wrong that you didn't plan on, you didn't try to mitigate them, you couldn't prevent what happened, or maybe you could have, but how do you handle the events now that it has happened? I don't like to single out companies as a rule, but there are plenty of examples out there, and I do have some examples here that I'll talk to where things did go dramatically wrong, and they were in crisis management mode, but it was always after the fact. So risk is really prior to the crisis occurring. Crisis is once it's happened, if you could think of it that way. So you got the systematic approach for dealing with risks. You also need a culture of risk management in a company. People need to recognize in their business environment that risk is real. It's always present. It's not going to go away. In fact, you could just stay at home in bed. You're still exposed to risks. There's always the fire risk at your home, for example. So it's not going to go away. It's not going to be zero. And you need to understand that. And you need to understand what to do about it, right? Some companies have very good programs for explaining to their employees the hazards in the workplace and what to do about them. When we talk about the maintenance environment, and probably electricians would be a good example. They wear a great deal of personal protective equipment when they're working on equipment that is energized. They've got the arc flash protection suits in the event that something goes wrong. And arguably, you could just turn everything off, but some work must be done with the equipment energized. So there is going to be a hazard associated with that. The best you can do is take every precaution out there. So people in those environments understand those hazards and what to do about them, and they prepare themselves, and hopefully things don't go wrong. But when they do, they're protected. So you need that culture of understanding it. Now, the next slide shows a bit of a risk management process, which I'm going to leave it at this high level. But every business has a context that it operates within. You're in the oil and gas industry, you're in pulp and paper, you're moving product by rail, or whatever. So there's a business context, and within that context, there are a number of risks that need to be identified. So it's important for a company to identify what could go wrong. Okay, and that's really what risk identification is all about. And we'll talk a little later about methods you can use for doing that. Then once you know what could go wrong, you want to understand the probabilities associated with that going wrong. So how likely is it that something will happen? And look at whether or not that risk is acceptable. So there's a bit of an analysis, an assessment of the levels of risks, and then you decide what to do about it. You're going to control it, you're going to just watch it. What are you going to do? And then monitor your activities. What have you decided to do? For example, using that electrical situation, if you're issuing the right personal protective equipment to your electricians, are they using it properly? Right, so you're going to monitor that. Are they actually using it when they should be, or not? Right, so that kind of monitoring has to happen, and then you may adjust your activities based on what you find in that monitoring. So it's a continuous improvement cycle, much like the Deming quality cycle, and it very much follows that kind of a flow. And that's a risk management process. Now, the types of risks you're dealing with, operational. We all know that when equipment fails, you're going to have to repair it, and there's basically a cost associated with that. We're going to probably budget those costs. There's downtime and lost production, often not budgeted, but chances are your production forecasts take into account your historical reliabilities and availabilities. So the risk associated with the equipment failure is almost built into the forecast, and it's hidden there.
Right.
Especially if you've had a bad history of maintaining your forecasts. There's revenue losses, of course, when things fail. There's quality impacts if the equipment's not working properly. There's safety hazards. Many accidents in the industrial environment happen around equipment failure and the activities to put them right. So um, slips, trips, and falls. You slip on stuff that leaked. You fall off of temporary structures. You don't typically fall off a flight of stairs that you use every day. And you trip over things that are there that aren't normally there. All right, and all of those things are associated with some form of equipment failure or the activities associated with correcting them. So the maintenance activity and equipment reliability has a potential big impact on safety.
So Jim, it seems to me that going through this process and deciding what the risks are, there's another question that I guess that you're asking here is it better to do something or not do something when you have this risk, right? Where does this take you?
When you've got an identified risk, you do need to decide: do I do something or don't I?
Right.
And that depends on, I guess, the probability of it happening, for starters, right? Like if there's a probability that you could be killed, for
Right.
example. You don't like to hear that, of course, but the probability might be incredibly low. Are you going to do anything about it? Well, if it's low enough, if it's below your level of tolerance, you'll probably do nothing. If it's above your level of tolerance, right? Like if you say, well, I'm going to accept the average for an office environment is about 1 in a million chance of being killed. Well, if I tell you that in this office you're so good it's about 1 in 10 million, you're probably going to do nothing about it.
Right.
But if it was more like 1 in 100,000, you might say, well, what's wrong with our office environment here? What are we going to do about that? So you're going to look at the risks and the consequences associated with them and then act.
Right. So
Or not.
I'm thinking about, and I'm probably jumping ahead to one of the examples that you'll be referring to is, for example, the Maple Foods example?
Maple Leaf Foods, yes.
Maple Leaf Foods, yes. With a crisis situation, for
Yeah.
example. Just going on that idea, because I'm tossing back and forth here, and okay, so you know that there are certain risks that could happen out of a situation, and then deciding, well, what should be done? What is the right course of action to take?
Yeah. Well, in that situation, there was an unfortunate incident. It led to the sale of product that was unsafe. People were killed. People were hurt. They had a crisis. Right. The risk, unfortunately, the risk hadn't been managed at that point.
Right.
They were now doing damage control.
So that
okay.
truly, that was what I was trying to get at. So what in that situation is the risk protocol? What is being followed there? So, but really, you're saying it's damage control.
At that point, it's damage control. In fact, all the examples I've got, which maybe we could just jump to,
Sure.
because we've got those on a slide here, and I think down around the second last one from the bottom is Maple Leaf Foods. We had 22 people die in 2008, another 57 confirmed cases of listeriosis. And it was because of basically uncleaned food processing equipment. Now, that's not to say it wasn't cleaned, but the cleaning process, the procedures didn't get rid of the contaminants, and the end result was product that had that effect. Now, it wasn't discovered until people started dying and getting sick. So you're in full-blown damage control at that stage. It's like the up at the top of the list, Deepwater Horizon and BP's experience there back in a few years ago. Good risk management would have suggested that there were things they could have done to the blowout preventer to make sure that it actually worked when it was called upon to work. And the fact is, it didn't. And they ended up with a chain of events that resulted in fatalities, major loss of equipment. Upwards of, I think, $500 million worth of equipment was lost. Major damage to the environment, a lot of loss of life in the environment itself. And needless to say, huge fines, probably lots of lawsuits. I'll bet the courts will be busy with that one for years to come. Again, that's all stuff after the fact. Good risk management would have said, do something about the blowout preventer before it happened. Now, that won't eliminate the probability that something could go wrong. Right? Even with good risk management, things can still go wrong, but it reduces the probability. The other thing, of course, you could do is reduce the consequence. Right? So if you know of a particular failure type that could result in some harm of some sort. There's possibly other ways to protect against that harm in addition to what you've already got. Okay, I look at some of these other examples. Lac Mégantic in Quebec just recently. Basically, a train was parked and the brakes didn't hold. Now firefighters had put out a fire on the engine and turned the engine off in the process. My understanding is the engine was actually used to keep air compressed, which kept the brake applied. The handbrakes that were in place were just insufficient in terms of number and possibly tightness to hold the train. It was actually on a slope. And it started moving. And once it starts moving, it's going to just go faster downhill. And that's what happened. It ended up derailing right in the, at the next big curve that it hit, which happened to be right downtown Lac Mégantic, and ended up killing a bunch of people. Could that be avoided? I believe it absolutely could be. Very dependent on two systems that worked independent of each other, one of which was turned off, albeit for good reason, but not turned back on again. Didn't anybody in the fire department ask why was the engine running in the first place and unattended?
Right.
Why weren't more manual brakes set? Did they follow standards? Possibly. I don't know all the details. But that's resulted in again, you'll see lots of litigation. MM&A Railway, they're already out of business. Their assets are being sold off. BP Texas City, 2005, big impact on production, also loss of life, also a lot of injuries when they had a major explosion. Safety equipment that was in place to prevent the kinds of things in the chain of events that occurred there didn't work. Operators arguably didn't understand their process well enough, didn't respond well. So there's a number of different things that have happened here, and you can point back to things going wrong that could have been managed better had they been identified better. And they weren't always done. Now, ways of identifying them are shown here on this slide.
So at this point, I'm going to ask that we pull up another poll as you talk about some of the methodologies as we get into that.
Mm-hmm.
We want to put out a question that says, which method or tool is most critical in risk analysis today? And we ask that everyone vote on what they may be using.
Right, and as they're doing that, I'll maybe explain a little bit here. Brainstorming is literally just that. We sit around a table or in a room and we say, what could go wrong? And people use their creativity to come up with ideas of things that could go wrong. HAZOP is a rather structured way of doing that, which is guided by a number of different terms, and there's a method that's applied. FMEA, failure modes and effects. By the way, HAZOP stands for Hazard and Operability Study. It's mainly focused on risks in operating environments associated with hazards. So it's not used across an entire system necessarily. It's only where you think there's a hazard. Failure modes and effects analysis is used often as a design tool at the early stages in engineering of a new product to look at. Predominantly, it's used for looking at design flaws or potential design flaws that need to be addressed, many of which will be safety related, of course. And then, of course, there's RCM, Reliability Centered Maintenance, which is a method for defining failure management strategies, used across multiple industries, typically on more critical equipment. All of these are very, very good at identifying risks and hazards in an industry. Different companies use different methods. Some companies use combinations or multiple of these. If we look at the poll results that are there on the screen now, looks like RCM is coming out at as the top.
Do you agree with that in your estimation?
Yes, I definitely do. I've actually, to me, RCM is a more complete method than FMEA. It includes FMEA. It doesn't exclude it. It's not different from it. It just goes beyond it and actually leads you down the path of making specific decisions. And it can be applied at the design stage or after the design stage. So I see it as being a bit more versatile than FMEA and more complete. HAZOP, I've actually run RCM analyses in parallel with HAZOP studies on the same system exactly and come up with more risks being identified from the RCM than we did from the HAZOP. and that was in a chemical plant environment. Brainstorming is very limited. You have to have the right brains at the table. It's as simple as that. And if you don't, you're not going to get the best results. So, and brainstorming also can be very much steered by a strong personality who has a lot of influence at the table.
So I've been hearing a lot about, at least reading, around buzzwords around RCM.
Mhm.
Hearing a lot about streamlined RCM versus classical RCM.
Mhm.
I'm sure you're going to get into what where we should not cut corners, but can you speak to that?
Well, yeah, the RCM itself comes out of the airline industry. And in fact, the study I referred to earlier, done by Nolan and Heap in the 70s, basically started that method going. It was a very technical, solid technical basis for making decisions about managing failures and their consequences. It's based on the premise that you're actually trying to maintain the functions of what assets do, not necessarily maintain the equipment itself. You really don't care about the equipment, it's just stuff. But what it does is what you really want. All right, so you don't buy a drill because you want to drill holes. You buy a drill because you want holes. So it's the function we're maintaining. If I can get holes without a drill, why not, right? So RCM, there's a variety of different approaches. They're basically different brands, if you will. Streamlined RCM is supposed to be a quicker way than classical RCM. Classical RCM is a particular brand. It's not really a brand. It's kind of a term used for one of the original methods of RCM that was developed. It's sometimes used to describe RCM2, which is another brand. There's RCM Light, kind of like light beer. I actually worked on developing that years ago before I got involved with RCM2. So there's different brands of it out there, and they all intend to do the same thing. Okay. Are there shortcuts? I don't believe there are, but I don't believe you need the thoroughness of a full-blown RCM analysis on everything. Right? I would only do it where the consequences of failure are fairly severe, so highly critical equipment. Okay, we've got a question.
We've got a question, and let's see if we can bring it up on screen. So, Jim, it says, how would you decide the amount of resources or effort to invest in risk? True RCM is very detailed and resource intensive.
Yeah, RCM has the acronym has been considered the resource consuming monster, as well as reliability centered maintenance. And indeed, it can be. And I like to manage that by only using RCM on the most critical assets. I don't use it on everything. Now, some industries like aircraft, for example, it's worth using on all the systems that are related to flight safety or could be related to flight safety, right? Now, arguably, things like the entertainment system doesn't matter if it fails. But if it fails in a way that creates a fire, fire on an airplane, you're sitting in a big cigar tube, a long way above the ground. Fire's bad news. So maybe even the entertainment system on an aircraft is worthy of having that thorough investigation. And indeed, aircraft systems are very thoroughly investigated. In a plant environment at ground level, okay, first of all, it's not going to crash in the same sense. I would really be looking at which equipment has the greatest potential disaster capacity, if you will, the greatest hazards, right? What could kill people if it fails? What could cause major environmental damage if it fails? What could cause a major loss of production if it fails? So I would manage that. In terms of, there's no magic number for how many people would I associate to it. I think you have to look at the actual systems installed, the nature of the industry, how much of it is critical, how much of it isn't. If it's a room full of sewing machines putting clothes together, you're not going to go do an awful lot of analysis on it. Certainly, loss of a piece of machinery isn't going to have a huge impact on production. But if you're talking a major compressor train in a refinery, where you might only have one major compressor train present, that has a huge potential financial impact, and the type of failure could also result in a major loss and release of hydrocarbons, which are, of course, quite dangerous. And there's lots of hot stuff around a refinery too. So usually a leak of hydrocarbons results in something a little bit more nasty than just a leak. So very difficult to give a good solid answer. How many would I put in there? But I would really take a hard look at the environment. Um, so dealing with risks, you can avoid them, prevent, design, training, procedures, processes, methods, you can change those. You can reduce them, have methods of detecting when things go wrong, predict them, again, deal with those with design and procedural approaches. You can transfer or share risks, you can outsource, you can retain the risk. Just let it happen, right? But you would only do that if you can live with the consequences. RCM itself has a tremendous history of risk reduction in aircraft. In fact, the rate of crashing aircraft today is about 1/120th of what it was back in the 1960s. So there's been a huge reduction in levels of risk when it comes to flight safety. Um, but people are surprised to find that there's still a lot of equipment on an airplane that is allowed to run to failure. All right, but if you think about it, does it really matter if the seat recliner doesn't work properly, or if the latch on the luggage bin doesn't hold tight? You can always use, although it doesn't look good in an aircraft, you could always duct tape it close if you had to. But when it comes to flight safety, right, engines, landing gear, keeping the aircraft pressurized, those kinds of systems, hydraulics for the control surfaces on the wings, that stuff better work.
You bet.
All right, and that's what RCM delivers, is in those very critical systems, you do exactly the right things to keep them working. It's also been used very successfully elsewhere. It's a functional approach. As I said earlier, your focus is on maintaining what the equipment does, not what it is. You follow a very rigid step-by-step method with RCM to identify what could go wrong, how it could go wrong, what happens when it goes wrong. You ask, what can I do about it proactively? And if there isn't something you can do proactively, then what do you do? Right? If you've got something that could fail and result in a major incident that you don't want to have happen, and there's no way of preventing it or predicting it, then you have to start thinking of alternatives. Do we redesign things, for example? There are other approaches. It's not always a maintenance activity, even though the name reliability-centered maintenance might suggest it is.
Right.
So in other industries, it's not always maintenance, that's for sure.
We should probably go into some of the standards and
Yes.
see where risk fits in this picture.
Yeah. Now, there is a very new set of standards that's been produced, and in fact, just January of this year, the International Standards Organization released ISO 55000, 55001, and there's actually a guide to 55001 called 55002. So there's actually 3 documents that kind of work together. The actual standard that says here's what you should be doing in asset management is 55001. Now, it cross-references to ISO 31000, which is a risk management standard that's been around for quite a long time. Okay, and I think I mentioned that one earlier in our talk here. So there are some very explicit links between the two. They certainly ISO 55001 cross-references to 31000. I'm tripping over the numbers here. And in it, there's a lot of talk in ISO 55001 about asset management risks. And if you think about it, physical assets impact just about every aspect of a business. Financial performance, production capacity and performance, your ability to deliver on time, quality, safety, environment, even security in some industries. So there's big impacts that failures of equipment can have for the business. And the asset management standard puts an awful lot of emphasis on managing those risks. So it ties in very nicely with the risk management standard and its intent. What's different about it is that risk management in the past has been largely, in organizations that actually deal with it, because not all do, there's typically somebody responsible for risk management in the company. It could be a vice president. I've dealt with vice presidents responsible for risk. And they're responsible for risk across the whole company. But in other departments within the company, it's often seen as, well, that's the risk management guy's job. So So there's this siloed kind of mentality. And the bigger the organization, the more likely that is to occur.
I was going to ask you just to speak more specifically to how companies are responding to this new focus on strategic risk, and what are you seeing?
Well, what I'm seeing now with the ISOs, people are learning at the moment. They're reading it. They're trying to find out what it really means to them. So they're not quite sure what to do at this point. Companies that have been exposed to RCM in the past, for example, companies that have hazardous environments, like chemical industry, for example, the food industry, they've already been using risk management approaches quite broadly. With the ISO coming out, people are starting to look more at risk in other industries. Right? It kind of came from the British publicly available specification 55-1 and its guidelines 55-2. The the whole concept of risk management really got a lot of airtime, if you will, in the UK specs, and that's showing up in the new ISO. So those specs that the Brits had were originally really written for the kind of utilities type industries, gas, electric, water, and that's where it came from. And there was a lot of emphasis on that in those specs. The ISO is written in a much more generic way to apply to virtually any industry. It's a voluntary standard, of course, but the risk management language is still very much alive in it. And anybody that's looking at it is going to start thinking about, okay, how do I have to manage risk in my environment, whether it's a cookie plant or rocket ship plant. In ISO 55000, there's a number of different topic areas which are listed on the screen here. It talks about the organizational context, which is, and when it comes to risk, it's that risk context we had on an earlier slide. There's a lot of leadership emphasis. None of this is going to happen without people actually making it important, and that's got to start at the top. Bottom-up approaches just don't work very well.
That's where the cultural shift comes in, isn't it?
It is a bit of a cultural shift because the top leadership in many companies is focused on let's make money, let's keep the shareholders happy, and we're not talking about just keeping the shareholders happy here. We're talking about keeping the employees alive. We're talking about the public interest, the neighbors of the plant or the business. Heck, even your public image, is important. So now all of that does contribute to making money, but it's not an exclusive focus on making money. I think that's the thing. And then there's, of course, these other activities that have to flow from that in order to have a good risk management framework in an organization and go through that process of identifying and dealing with the risks. I guess the message here is that risk is a hot topic. It will continue to be a hot topic, and it's getting to be even more of a hot topic as time goes on. When things go wrong, everybody hears about it. Big accidents make big news. And there's a lot of finger pointing. There's a lot of people running and hiding when that happens. It's very much in the public eye these days. And there's a tendency when things go wrong to start blaming and punishing and suing and so forth, which really doesn't do any good at all for the victims. We want to be more proactive and avoid these things from happening, and that's what risk management is all about. Let's either reduce the probabilities, let's reduce the actual hazards, or find some way of mitigating the consequences when those things do go wrong. And good risk management is actually a blend of all of those. Mm-hmm. So we've got methods that have been out there for a while, FMEA, HAZOP, RCM, they've been in use for years. People that have used them recognize them as good risk management tools, even if they didn't call it that. The UK's PAS 55 series really brought risk to light in the asset management world. And I think I give the UK credit for making risk part of the asset management terminology. I don't really believe it was before those specs came out. And that's only in 2004 when the first one was published. That's not that long ago. The new ISOs are an amazingly good document, I believe, and it's far more general than the UK's spec was. So they've got a broader audience. They're voluntary, but I think you're going to find regulators looking very hard at it and saying, look, there's no excuse now. This is out there. It's in the public domain. Uh, why would you allow things to go wrong in your plant when you've got these fantastic guidelines that are out there that you could be using? Why didn't you use them? You know, even though they're voluntary and they're not required, it's pretty hard to say I didn't know about it anymore. Certainly, lawmakers are going to start looking at it when things go wrong. I think you're going to see, next big accident happens, number of people are going to be killed, and people are going to start saying, well, how can we prevent this from happening? The lawmakers with, very good intentions will jump in there and say, do this, do that. And that's what they do. And now they've got actually a standard that came out of the asset management industry that they could utilize, as opposed to coming up with rules and things that may not always make sense.
Right.
It's sad, but disasters heighten our awareness. I was once asked at a conference, when do you think PAS 55 is going to become mandatory over here? And I said, when the body count gets high enough.
Ouch.
It's a sad commentary, but that's what drives some of these things. And as much as I hate to think of it that way, it's what I see. And that's just an observation. Risk's a big part of your business. It's going to be a big part of any business, and it's not going to go away. As I see it in the asset management world, because of the impact we have on all aspects of the business, we have a responsibility to manage those physical risks from our assets much better than we have in the past, which means a lot more emphasis on it. We just have to get a lot smarter.
Jim, I think this is a great point to round up. I think we're just approaching the end of our time limit. So I'll round up by saying, at least what I've learned from you today is that the way to fully address an issue is to either do it right the first time or risk paying more for doing it later, right?
Mm-hmm.
You advocated that embedding an enterprise-wide program, risk management program, is clearly the way to go. And it requires integration of all risk-related functions, your risk management, internal control, quality, compliance, everyone needs to be involved.
Mm-hmm.
And you also emphasize that this takes planning, resources, treating risk implementation as a major change program, and it's not just a project. So I'd like to thank you for an informative discussion today. Jim Reyes-Picknell of Conscious Asset Management is our featured presenter today. I look forward to engaging with you again in part 2 and part 3 of this webinar series. And thanks also to our sponsor, Mobile Industrial Lubricants, for making this educational presentation possible. And thank you everyone for joining us today. Should you have any questions, don't hesitate to email me at rbeg@annexweb.com. So your feedback is very valuable to us. So I ask that you please fill out the survey at the end of this presentation. And thank you everyone for joining.